Good morning, dear students. We'll try to do some problems on the dual nature of matter, beta. Sure. See this question, beta. A particle capital A of mass m and initial velocity v collides with a particle capital B of mass m by 2, which is at rest. Stop. The collision is head-on. The collision is your head-on and elastic. Collision is head-on and elastic. So the ratio of the de Broglie wavelengths, the ratio of your de Broglie wavelengths, lambda A to your lambda B after collision is So there is a given question for us, basically. Very good question, madam. Little bit of your first year application is also been involved in this one. So read the question carefully. We got a particle capital A of mass m and initial velocity v, which has been colliding with a particle b of mass m by 2, which is at your rest. The collision is head-on and elastic. The ratio of your de Broglie wavelength of lambda A to your lambda B will be equal to your how much? Okay. This is your particle beta of mass m moving with velocity, particle A of mass m and initial velocity of your v collides with a particle b of mass m by 2, which is at rest. So it is colliding with your another particle of mass m by 2, which is at your rest, and initial velocity of this one is equals to your how much for me? 0. Then after collision, the collision is head-on and elastic, the ratio of their velocities. And after collision, this first body will be moving with velocity v1. This is your A and this is your m. And this is your another body of mass of your m2 and b, and velocity of this one is nothing but of your v2. Okay. So first body is moving with velocity v. Second body is at rest. After collision, the first body will move with velocity v1 and the second body will move with a velocity of your v2. So for head-on elastic collision, you already know that for head-on elastic collision, so if I'm talking about your head-on elastic collisions, velocity v1 is equals to m1 minus of your m2 divided by your m1 plus of your m2, m1 plus of your m2 into your u1 plus 2 times of your m2 divided by your m1 plus of your m2, this is into your u2. Okay, so u2 is how much better right now here? This is your u2 and this one is your u1. u1 is moving with the velocity of your v and u2 is equals to 0. u2 0 అదంటే ఇది మొత్తం 0 అయిపోతుంది. So v1 will become how much for me? v1 is equals to, isn't it, m1 minus of your m2. m1 is how much? M. So it is m minus of your m by 2 into divided by m plus m by 2, m plus of your m by 2 into u1 is given as of your what? Velocity of your v. Okay, so m minus m by 2 is m by 2 plus m plus m by 2 is nothing but 3m by 2. So this m will get cancelled right now from this one. So this will become for me how much? This will become for me v by 3 అంటే కదా e2 also will get cancelled right now. ఇక్కడ velocity v ఉంటుంది కాబట్టి, so this one is your v by 2 into your 2 by 3. So this 2 will get cancelled, so this will be equal to v by 3 meter per second. That means after collision v1 velocity వచ్చేసి v1 by v by your 3. In the same way v2, if I am writing v2 is equals to, what is the formula? m1 minus of your m2 divided by your m1 plus of your m2 into, this will become right now u2 plus 2 times of your m2 divided by your, in the place of your m1 you try to take it as of your m2. That means this will become for me m1 divided by your, this will become for me how much right now? m1 is nothing but m1. This will become for me your m1 divided by your m1 plus of your m2. This is m2 minus m1, this is m2 minus m1 into, here it is right now here in the place of your m1 I'll write here is nothing but of your u1. So u2 is equals to how much for me beta? 0 kada. u2 is equals to 0 kabatti, so this total term will become 0. So v2 will be equal to your 2 times of m1 is nothing but m divided by, this one is m plus of your m by 2 into your u1. u1 is nothing but equal to how much for me beta? u1 is nothing but equal to your v, antena. So this one is equals to your v. So this one will become for me 2m into v divided by your 3m divided by 2. This one will get cancelled. So this will become for me 4 into v divided by 3. So this is your v2. So we got the velocities v1 and as well as of your v2. After collision, de Broglie wavelength of lambda A and lambda b will be equal to how much beta? After collision, de Broglie wavelengths, de Broglie wavelengths of A and B are wavelength of your A, de Broglie wavelength of A is equals to h by your m into your v1. Okay, so that will be equal to your v1 value. How much we got right now? V by 3, isn't it? So that is equals to your h by your m into v1 is equals to v by 3. That means this will become 3h. Wavelength of the b is equals to your h by your m into your v2. So that will become to your h by your m into v2 value. How much we got right now? 4v divided by your 3. So 3h by your mv will get cancelled right now for this one. Then so it is a 3h by your, this will become for me mass of this one is also your m2 kada. So this will become for me m by 2. So this is 2 ones are, this is 2 twos are, and this will become for me 3 into your h divided by your, this one is nothing but 2 into your mv. So we need to calculate the ratio. Lambda a by your lambda b will be equal to your 3h by your m into your v into, this will become for me divided by your 3h kabatti, this will become for me 2m into your v divided by your 3 into your h. This 3h, 3v and 3v gets cancelled, so that will be equal to 2. That means wavelength of your A divided by wavelength of your B will be equal to your 2. Is it clear? Good question, madam.
सर ఒకసారి పేజ్ 2 ఓపెన్ చేయరా?
और है बेटा?
कंप्लीट सर।
Done. Next question. We got two particles move at right angles to each other. At right angles to each other. Right angles to each other. Their de Broglie wavelength. Their de Broglie wavelengths are lambda 1 and lambda 2. Lambda 1 and lambda 2 respectively. The particles suffer the particles suffer perfectly inelastic collision. Perfectly inelastic collision. Perfectly inelastic collision. The de Broglie wavelength. The de Broglie wavelength lambda of the final particle of your final particle is given by this one was 2019 JEE mains question. Very good question. Two particles, again application of your collisions have been involved even in this question right now. So we have got right now for me what two particles which are moving at right angles to each other. So first try to write the statement what he has given for me. So we have got two particles. So this is your first particle. Momentum of this particle is in this direction. Like say it is a P1. So that will be equal to H by your lambda 1 momentum. And this is your another particle. Momentum of this one is perpendicular to this one in this direction. So P2 will be equal to H by your lambda. Both of them are perpendicular. So I can write here P1 is equals to H by lambda 1 into your I cap, and P2 is equals to H by your lambda 2 in your J cap. Both of them are perpendicular. Now, what type of a collision they are? The perfectly surface, perfectly inelastic collision. Do you know that in any collision, momentum conservation has been applied? So, using momentum conservation, in all the collisions, momentum is said to be conserved. That means total momentum P bar will be equal to your P1 plus of your P2. Both of them are perpendicular. So magnitude of this one, if I am writing, this will be equal to I and J are perpendicular kabatti. So this one is H by your lambda 1 into your J cap. Sorry, I cap. H by your lambda 2 into your J cap. J cap L is also equal to 1. Isn't it? So from this one, I can write the values part of the de Broglie wavelength of this particle will be equal to how much beta? So de Broglie wavelength of this particle will be equal to how much?
So 1 by lambda square equals to lambda 1 square plus lambda 2 square.
Yeah, because this can be written as of your H by lambda, that is equals to under root of this one is your H square divided by lambda 1 square plus of your H square by your lambda 2 square. So in the anni lambdas gets cancel and the root kuda idu velipothe enta avutundi right now. This will become for me 1 by lambda square is equals to 1 by lambda 1 square plus 1 by your lambda 2 square. So this one was the relation between them. Good question. Okay now. Clear? Sure. Next question, Luna. 50 watt per meter square energy density. Energy density means energy per unit volume. Energy density of sunlight, of your sunlight, is normally incident on the surface of a solar panel, on the surface of your solar panel. Some part of incident energy, that is 25%. 25% is reflected from the surface, and the rest is observed, The force exerted on 1 meter square surface area will be close to, take C is equals to 3 into 10 to the power of 8 meter per second. This one was also asked in 2019 JEE mains question. President, I already told you this such type of models. 50 watt per meter square is energy density of the sunlight is normally incident on the surface of a solar panel. Some part of incident energy, that means 25% of it is reflected from the surface, and 75% is observed, 25% is reflected, and the rest is observed. The force exerted on 1 meter square surface area will be close to how much? So idi oka panel anukundam, solar panel. ఈ సోలార్ ప్యానెల్ పైన మనము రే ఆఫ్ లైట్ ని ఇట్లా ఇన్సిడెంట్ చేసాం. ఓకే, అండ్ దిస్ ఈజ్ యువర్ ఇంటెన్సిటీ is equals to power by area. Power unit ఏమో వాట్, ఏరియా. And in this one, certain amount is reflected back in the upward direction. How much amount is been reflected? 0.25% of your eye. అంతే కదా, 25% అంటే. Now pressure on the surface due to this incident light will be equal to how much beta? Pressure on surface due to incident comma reflected and observed radiation is so P is equals to 0.25 times is reflected, that means 2I by your C, plus 0.75 is observed, ante I by your C. Okay na? So this will become how much for me? This one is 2, so this one is 1.25 times of your I by your C. That means this is 1.25 into intensity is given as of your 50 by area is velocity of light 3 into 10 to the power of your 8. So simplified, you will be getting the pressure, isn't it? So that's what is asking there, isn't it? So the force exerted on 1 meter per second square, force exerted on 1 meter, force per unit area. So what is the force per unit area? Pressure only, na? So force exerted on 1 meter per meter square surface area will be close to your how much is asking. So pressure is equals to your force by your area. So that's what you have given the given condition. ఎంత వస్తుంది చూడండి. This power will go up. This is 1.25 into 50 divided by 3.
So
This is
20.8
approximately 20.10
into 10 to the power of -8.
to the power of -8 Newton. Very good question, beta. Okay, na? డ్యూయల్ నేచర్ నుంచి టూ క్వశ్చన్స్ అడిగాడు నాన్న. ఇప్పుడు 2019 8th April రెండు క్వశ్చన్స్ అడిగాడు, 9th April 2 క్వశ్చన్స్ అడిగాడు, 10th April 2 క్వశ్చన్స్ అడిగాడు, అండ్ 8th రెండు అడిగాడు, 12th Jan 1 అడిగాడు, 10th Jan 1 అడిగాడు, 11th Jan 1 అడిగాడు. సో ఆల్మోస్ట్ ఆల్ రెగ్యులర్లీ టూ క్వశ్చన్స్ అడుగుకుంటూ వచ్చాడు వాడైతే డ్యూయల్ నేచర్ పైన. ఇంకో క్వశ్చన్ ఉన్నాను, వెరీ గుడ్ క్వశ్చన్. లైట్ ఈస్ ఇన్సిడెంట్ normally on a completely absorbing surface with an energy flux of your 25 watt centimeter inverse square. If the surface has an area of 25 centimeter inverse square, the momentum transferred to the surface in 40 minutes time duration will be. Okay, chalo, try to do it out. Try cheyandi andaru sir. Light is incident normally on a completely absorbing surface with an energy flux of your 25 watt per centimeter square. Ante intensity. Now what is the radiation pressure on the surface beta when it is completely incident? Pressure is equals to, in terms of intensity, I by your C. Formulas గుర్తుండాలి నాకు. ఇది పడంగానే ఏమైపోతుంది రైట్ నౌ, ఆల్ ది పార్టికల్స్ విల్, అంటే సడన్ గా దీనిపైన ఫోర్స్ ఎగ్జర్ట్ అయింది అనుకో, మొమెంటమ్ ట్రాన్స్ఫర్డ్ విల్ బి ఈక్వల్ టు హౌ మచ్ ఫర్ మీ?
Force into delta T.
Momentum transferred in time delta t, small time అనుకుందాం, is nothing but what? Impulse kada. Impulse is nothing but what? Force acting for very small interval of a time, F into your delta t. So impulse J is equals to your F into your delta t. Force value ఎంత ఉంది? I by your C into this one is nothing but of your force is nothing but pressure into area. So this one is nothing but of your pressure into your area A into your delta T. So this is your impulse. I by C into A into your delta T. So that is an impulse imparted. So J will be equal to intensity is 25 into 10 to the power of 4 divided by velocity of light 3 into 10 to the power of 8 into area 25 centimeter kabatti 10 to the power of minus 4 into time is 40 minutes kabatti 40 into your 60. So then simplify cheyandi, that will give me the impulse.
So 5 into 10 to the power minus say Newton per second, sir.
Yeah, 5 into 10 to the power of minus 3 Newton second will be the answer. Good question, beta. Student, light is being incident on the completely absorbing surface with an energy flux of this much. Energy flux means intensity per your unit area, power by area. If the surface has an area 25 centimeter square, the momentum transferred to the surface in time 40 minutes unto. Momentum is nothing but what for me? Impulse only, na? Impulse is equals to your force into your delta T. Force acting is nothing but equal to what for me? Pressure into area. Pressure acting on that one is intensity by your area. Okay, simplify that one, I'll get the answer for the given condition. Good question, ma'am. Important model and inkoti. Two electrons are moving. Two electrons are moving with non-relativistic speeds. Non-relativistic speeds perpendicular to each other. Perpendicular to each other. Perpendicular to each other. If corresponding de Broglie wavelength, corresponding de Broglie wavelengths are lambda 1 and lambda 2, their de Broglie wavelengths in the frame of reference attached to their center of mass is first option is lambda of center of mass is equals to lambda 1 is equals to lambda 2. Second one is 1 by lambda center of mass of this one is equals to your 1 by lambda 1 plus 1 by your lambda 2. And third option is lambda of your center of mass is equals to 2 into lambda 1 lambda 2 divided by under root of your lambda 1 square plus lambda 2 square. And fourth option is lambda of center of mass is lambda 1 plus lambda 2 divided by 2. So read the question everyone and try to do it out better. Vachinda? Anyone? Two electrons are moving with non-relativistic speeds perpendicular to each other. If corresponding de Broglie wavelengths are lambda 1 and lambda 2, the de Broglie wavelength in the frame of reference attached to their center of mass will be equal to your how much? See, before exploding of that particle, before they are moving, this is your center of mass of the particle. This is the center of mass. Now, after one, this particle and this particle, both of them are moving perpendicular to each other. So one is moving in this direction with velocity v1. This is one electron. And another is moving in the upward direction. This is your v2. This is your another electron. And this is along your y-axis and this is along your x-axis. An angle between them is 90. Two electrons are moving with their non-relativistic speeds perpendicular to each other if corresponding de Broglie wavelengths are lambda 1 and lambda 2. So as v1 is equals to how much beta? v1 bar is equals to v1 into your I cap. So v1 will be equal to how much beta? H by your m into your lambda 1 into your I cap, because lambda is equals to h by your m into v gada. So v is equals to, I can write h by your m into your lambda. Also, we can write right now de Broglie wavelength right now for the second one. V2 bar is equals to your V2 into your in which direction beta? J cap. So that is equals to h by your m into your lambda 2 into your j cap. So I can get the value of lambda 1. Lambda 1 is equals to h by your m into your v1, and lambda 2 is equals to h by your m into your v2. Now, vector speed of center of mass enta nana manam kinematics lo nechukunnamo in the first year chapter, velocity of center of mass. Velocity of your center of mass mvcm is equals to your, we'll be writing m1 v1 plus of your m2 v2 divided by your m1 plus of your m2. Mass is same kabatti this will become for me half into v1 bar plus of your v2 bar. M1 plus M2 is nothing but 2m, and this one is m part of relation. That means velocity of your center of mass is equals to your half into your v1 value already we got right now. So what is the value of your v1? v1 is equals to h by, so this one is your h by your m into your lambda 1 I cap plus of your h by your m into your lambda 2 in terms of your j cap. So that is equals to your h by your 2 into your m common I can take right now. So this one is your h by m. It is 1 by lambda 1 into your I cap plus 1 by lambda 2 into your j cap. So this is a velocity of your center of mass of this one, isn't it? In reference to the frame of center of mass beta, velocity of the first electron traveling in x direction is given by. So if reference frame of center of mass in reference frame of center of mass, velocity of first electron traveling in x direction, in your x direction is given as velocity of the first particle with respect to center of frame is equals to v1 bar minus of your v2 bar. Okay, so we already got the velocity of your center of mass beta. So it is nothing but of your v2 part of relation. So we need to get the velocity of your center of mass of the given condition. So we got the value of your lambda 1, we got the value of your lambda 2 part of relation. That means velocity of the one with respect to c is v1 minus of your velocity of your center of mass of the second particle, that is h by your m into your vcm. Okay, so it is nothing but of your velocity of the first particle minus of your velocity of center of mass of the given frame part of relation. That means this one will be equal to v1 bar minus of velocity of your center of mass of your frame. Okay, that means I can write this one as of your velocity of one with respect to c is equals to h by your m into lambda 1 into your I cap minus This one is h by your 2m into your lambda 1 into your I cap, plus this one is h by your 2m into your lambda 2 ఇది lambda 1 into your j cap. So this I cap will get cancelled right now for this one. ఏమన్నా అవుతుందో చూడండి, కాదు, sorry. Velocity of this one will become for me h by your, this one is 2m into your lambda 1 into your I cap minus, so this will become for me how much beta? ఎంత అవుతుంది చెప్పండి? One time కదా, అంటే this will become for me your 2m into your lambda 1, so it is half. This one is minus minus, this one will become for me h by your 2m into lambda 2 into your j cap. 1 minus 1 by 2 is nothing but 1 by 2 only, అవునా కదా? So magnitude of this one will be equal to how much for me? If I'm taking the magnitude of this one, so h by your 2m is nothing but out, so this one is under root of your 1 by, this will become for me how much for me? ఎంత అవుతుందన్న? h by your 2m, so this will become for me h by your 2m, so it is your 1 by your lambda 1 whole square, antena? So I can write this one as 1 by your lambda 1 whole square plus 1 by your lambda 2 whole square. Okay, so well, wavelength అడిగాడు అనుకోండి ఇప్పుడు right now, de Broglie wavelength of the first electron in center of mass of your frame. So we got this one as the velocity of your 1 in the center of your frame part of your relations. What we need? De Broglie wavelength, de Broglie wavelength of first electron in center of mass frame is given as, use the de Broglie wavelength formula, lambda of your 1c will be equal to h by your m into velocity of your 1 into your c. So that is equals to h by your m into, this is 1 by vc, that means this will become for me 1 by under root of your, this one is nothing but 1 by lambda 1 square my plus of your 1 by your lambda 2 square, isn't it? So how much I'm getting, you see, lambda 1c will be equal to endana
V1C కి h by 2m ఎటు పోయింది సార్?
h by ఇది కూడా ఉంది, సారీ, v1c కి h by కూడా ఉంది కదా, so this will become for me ఇక్కడ h, sorry, it is h by your 2 into your m, అంతేనా? సో ఇది క్యాన్సిల్ అయిపోతుంది ఇక్కడ, h by m క్యాన్సిల్ అయిపోతుంది, అంటే this one is how much for me? 1 by 2 into, this is 1 divided by your under root of 1 by your lambda 1 square plus of your 1 by your lambda 2 square. దీన్ని సింప్లిఫై చేయండి, ఎంత వస్తుంది? lambda of your 1c will be equal to ఎంత అవుతుంది చూడండి, ఇది 1/2 కూడా కిందికి వస్తుంది కదా, ఇది 1/2 అంటే ఇక్కడ this is divided by 1/2 అంటే 2 పైకి వెళ్ళిపోతుంది, so this is 2 into, this will become for me lambda 1 into lambda 2 divided by under root of your, this one is lambda 1 square plus of your lambda 2 square. This was one of the toughest questions asked in the dual nature beta. చాలా మంది తప్పు చేశారు అకాడమిక్ ఇయర్ లో, ఎందుకంటే ఇట్ రిక్వైర్స్ a lot of center of mass application కూడా, సో కొంచెం జాగ్రత్తగా మరోసారి ప్రాక్టీస్ చేయండి. సో థర్డ్ ఆప్షన్ మస్ట్ బి ది ఆన్సర్ ఫర్ దిస్ క్వశ్చన్. ఓకే, సో మరోసారి చదవండి, ఏదైనా అర్థం కాకపోతే ప్లీజ్ లెట్ మీ నో. సో నేను ఏం చేసిండంటే ఇనీషియల్ గా 2 particles center of masses are perpendicular అన్నాడు, సో ఐ రిటన్ v1 v2, I have got lambda 1 and lambda 2, and I'm using the velocity of center of mass concept ante mv1 plus m2 v2 divided by m1 plus m2. I got velocity of center of mass. Now in reference to the frame of your center of mass, velocity of the first electron traveling in x direction will be equal to how much? So v1 will be equal to how much for me? v1 minus v2. v2 is nothing but velocity of center of mass with respect to your center of mass గురించి మాట్లాడుతున్నాం మనం. So v1 minus vcm చేయండి, that will give me the answer for the given question. Okay na? మీకు ప్రీవియస్ ఇయర్స్ జేఈ మెయిన్స్ క్వశ్చన్స్ పేపర్స్ పంపించాను చూడండి, దాంట్లో నుంచి అన్ని క్వశ్చన్స్ కంప్లీట్ చేయండి సార్. ఫోటో ఎలక్ట్రిక్ ఎఫెక్ట్ క్వశ్చన్స్ అవన్నీ తీసి కంప్లీట్ చేయండి. నోట్స్ వచ్చిందా అందరికి? Chalo. Come to next chapter beta, atomic structure. Atomic structure. First one is Bohr's atomic model. Bohr's atomic model. Okay. It is the first successful experiment for hydrogen spectrum beta. You can write this one. This is first successful experiment for hydrogen spectrum. Okay, this model was developed for hydrogenic atoms. Hydrogenic atom. What do you mean by hydrogenic atom beta? One electron system. One electron system like plus Ze, isn't it, is known as one electron system. Example చెప్పండి అనుకోని, hydrogen, helium plus, lithium plus 2, beryllium plus 3. So this was the hydrogen spectrum for the hydrogenic atoms part of relation. So Bohr's model was the first successful experiment for hydrogen atom, and this model was first developed for the hydrogenic atoms only, in which we are talking about only one electron system, that is plus Ze or one electron system part. Example like hydrogen I can take helium plus lithium, beryllium plus 3 part of relation, go on for the given condition. And this model was explained in 3 basic steps beta. I hope you remembered all the conditions right now. Can write that point here also. This model was explained in 3 steps, or I can say postulates. 3 postulates, isn't it? So what is the first postulate beta? Gurtunda? First postulate of Bohr's model. First postulate of your Bohr's model. Gurtunda evarkana? All the electrons will be revolving around the nucleus in the circular path. Like say for example, if I am taking the nucleus, that is a plus Ze, electrons have been revolving around this one in the circular orbit, isn't it? So this one was your electron E minus, was moving with a velocity of your V, and this one was the force which has been acting toward the center, that is nothing but of your F centripetal force, and electrostatic force was been acting in the opposite direction. So this one was your electrostatic force, and this one was of your centripetal force. When the electron was been revolving in the circular orbit part of relation, electrostatic force was equal to your centripetal force. So I can write here F electrostatic force is equals to your centripetal force. You already know that how to write the electrostatic force between these 2 charged particles beta. In the electron, idu vachesi plus of your Z into your E part of relation, isn't it? So how do you write this one? So 1/4 pi epsilon, I'm taking it as of your constant, that is a K into Z into E into your E divided by your R square. Distance between them is nothing but of your R square. E distance R undi anukundam. So that is equals to centripetal force M into V square divided by your R part of relation. In this one, this r, this square will get cancelled right now. So I can write from this one relation right now. M into your velocity of your nth orbit, that is m into Vn square, is equals to k into z into e square divided by radius of your nth orbit. Okay, so this was your first statement of your Bohr's model of an hydrogen atom, that all the electrons revolve around the nucleus in a circular path, and you will never lose the energy part because it has been balanced by the centripetal force. That is the reason it continuously try to move in the circular path. So equating the centripetal force and as well as of your electrostatic force between them, I'm getting the relation m into velocity of your nth orbit is equals to k into z into e square divided by your rn. What is the value of k beta here? Anyone tell me? K value is equals to how much here? 1 by 4 pi into your epsilon naught. And value of this one is 9 into 10 to the power of your 9. Clear? Chalo, this was the first postulate. Next one is nothing but of your second postulate. Second postulate of your Bohr's atomic model. What is the second postulate, beta? Can anyone tell me? Bohr observed that all the electrons around the nucleus have some specific values of angular momentum, beta. So that means when a body is moving only on the centripetal force, angular momentum will always remain constant. So an electron revolve only in those specific orbits in which angular momentum of the electron is quantized. That is the second postulate of that one. Basically, I'm writing the statement directly. Electrons revolve only in those specific orbits in which angular momentum is conserved. Angular momentum of electron is quantized. That means L is equals to angular momentum formula gurtundi kada rotational mechanics la. L is equals to your m into velocity of your nth orbit, radius of your nth orbit. So that is equals to your from the given condition. M into Vn can be written as right now for the given condition. This is also equal to your integral multiple of n into your h by your 2 pi. N into your h by your 2 pi. This is your second postulate of your Bohr's model. Angular momentum L is equals to your m into Vn into Rn. So substitute the values where we getting this one as equals to your n into your h by your 2 pi. That means stable orbit around the nucleus is 1, for which both the equation 1 and 2 are being satisfied, beta. The first equation what we are written, this is your equation number 1 and this is your equation number 2. So what is the given condition? I can write here a note. Stable orbit around the nucleus. Stable orbit around your nucleus is 1 for which both equation 1 and 2 are satisfied. 1 and 2 are satisfied. Okay. So what is the condition I'm taking? Angular momentum of an electron is quantized antunam. Ante enti? Like see here, if I'm drawing the diagram right now, this is your electron which is been revolving in the circular orbit. So this one was the central part of your nucleus and this one was of your R. When this electron is been revolving, it is in the form of your what beta? Wave. In the form of your wave like this. Okay. Now see, the distance between one wave to your another wave is nothing but what? Wavelength together, lambda. That is nothing but equal to your lambda. And this is the electron which is been orbiting around the nucleus. It is not exactly circular. It is something like a zigzag manner like this, isn't it? So angular momentum of electron is quantized ante angular momentum of electron is quantized. Ante this electron, this is moving in what circle kabatti 2 pi into your R is equals to integral multiple of your wavelength. Any wavelengths unnai chudandi ikkada 1 2 3 4 5, like that is n part of relation, isn't it? And we know that wavelength lambda is equals to how much for me? H by your p, or that is equals to h by p is nothing but m into your v, isn't it? So from the given relation right now, lambda is equal to your h by your 2 pi, h by your m into your v part of relation. So I got the wavelength lambda. Substitute this one in the equation 1. So if I substitute in this equation, so this will become for me 2 pi into your r is equal to your n into lambda is equals to h by your m into your v, isn't it? That means mv into r ikkada తీసుకెళ్ళిపోతే ఇక్కడ ఏమైపోతుంది? mv into your r is equals to n into your h by your 2 pi. This is the way how we got the derivation right now. 2 pi ఇక్కడికి వచ్చేసింది, mv into r ఇక్కడ వెళ్ళిపోతుంది. So mv into r is equals to n into your h by your 2 pi. That means angular momentum is equals to your n times of your h by your 2 pi. That means angular momentum is directly proportional to your nth orbit. So this is the formula of your second postulate derivation. How we got that one basically. L is equals to your n into your h by your 2 pi part of relation. Very important one for your competitive examinations. Better. First one is right now for me what? Every electrons revolve around the nucleus in the circular path. So that is the reason electrostatic force is balancing the centripetal force. So we are getting the relation mvn square is equal to k into z square by rn. Second postulate says that electron revolving only in those specific orbits in which angular momentum of electron is quantized. That means L is equals to mv n to rn, that is equals to n into h by 2 pi. The stable orbit around the nucleus is the one for which the both equation 1 and equation 2 are satisfied. Now how I got this relation I'm explaining you see here. When electron is been revolving around the nucleus in this one, the total circumference of that one is equals to n times the wavelength, that is n into your pi lambda. And we know that lambda is equal to how much for me? H by p, p is equal to m into v. So substituting this value of your lambda in this one, we're getting 2 pi r is equal to n into h by your m into v. M into v you take on other side, so mv into r is equal to n into h by 2 pi. So angular momentum is equal to how much for me? Angular momentum n is equals to your h by your 2 pi. Very important relation beta. This one is your equation, which is the very important equation for your competitive examination. And this is your first postulate. Okay. Chalo. Third postulate. What is the third postulate of your Bohr's model? Can anyone help me out? What is the third postulate of the Bohr's model? See here. In a stable orbit, electrons energy remains constant. Electrons energy remains constant. Then energy up to constant undala. So when electron energy changes, I mean to say when it gets transit from one orbit to another, so during that transition instantaneous process, it involves the quantization of energy in the form of electromagnetic radiation. So that is your second postulate. That means in a stable orbit, electrons remains constant. So electron energy when it is transition from one orbit to another orbit at its energy level, during such transitions are instantaneous and involves the quantization of energy in the form of what? Electromagnetic radiation, which we call it as of your photons. Energy constant undal kabatti, the immediately remaining part is being filled by the other orbit. Ante what I am trying to say is electron energy changes. Electron energy changes when it makes a transition. When it makes a transition from one orbit to another. One orbit and in the energy. Orbit is your energy level beta. This is your energy. One energy level to your another energy level. So during such transition, such transitions are instantaneous. You don't get the time to identify that one. So they are instantaneous and involves and involves quantized energies and quantized energies in the form of electromagnetic radiations. ఇక్కడ నుంచే మనకి రేడియేషన్స్ అనేది వచ్చాయి. Electromagnetic radiations of photon. Okay, now see, if I tell you with the help of diagram, if this is your energy levels, this one is a n1 and this one is a, for example, n2. Now if electron is being present in this one, ఇక్కడ electron ఉందనుకో right now, e1, ఈ ఎలక్ట్రాన్ ఇప్పుడు ఇక్కడ నుంచి జంప్ చేసి n2 కి వెళ్ళాలి. n2 కి వెళ్ళాలంటే what it will try to do, it will try to take the energy from outside. So దీని ఏం చేయాలి మనకు, absorption, isn't it? So absorption photon అంటే ఈ ఫోటాన్ అనేది అబ్జర్ప్షన్ ఫోటాన్ ఎనర్జీ, దీనికన్నా మనం ఎగ్జాక్ట్ చేసుకుంటే ఇట్ విల్ అబ్జర్వ్ ది ఎనర్జీ అండ్ ఇట్ విల్ ట్రై టు గో టు యువర్ హయ్యర్ ఎనర్జీ స్టేట్. ఓకేనా, it is going to your higher energy state particulation. If it is coming from your n2 to your n1, it will be released a photon. Here it will be absorbing a photon, and if you are coming from higher energy level to your lower energy level, ఇక్కడ నుంచి వస్తున్నాం అనుకోండి. Okay, one electron is present in this one, e minus, this one is your n2 and this one is your n1. So you are coming from your n1 to your n2 like this, isn't it? In this process, photon is released. Photon is released. One photon is released, it will lose the energy, so it will fall from your higher energy orbit to your lower energy orbit particulation. So here E2 will be always higher kada. From higher nunchi lower ki ravalante, right now what is the condition right now? Change in energy delta E is equals to your energy in the second orbit minus energy of your first orbit. So that is equals to h into nu, or that is equals to your hc by your lambda. So I can say right now E2 is greater than of your E1. E2 is greater than of your E1. So it may either release the energy or absorb the energy. So it may release or absorbs energy. Okay, depending upon the excitation or de-excitation. If it is exciting, it absorbs the energy. If it is de-exciting, that means if it is coming from higher energy level to lower energy level, it will release a photon and comes to the lower energy conditions part. So that is about your three postulates you need to remember for your Bohr's model of your atomic structure. The first one is nothing but it is only associated with your one electron systems like hydrogen, helium plus lithium plus 2, beryllium plus 3. And the three postulates of that one is, first postulate says that every electrons revolve around the nucleus in the circular motion. You can see the definitions from your reference material beta. I'm directly writing the equations right now here. So centripetal force must be equal to your electrostatic force. You will getting one statement. Second postulate says that every electron which has been revolving only in those specific orbits in which angular momentum is said to be conserved. That means L is equal to your n into your h by your 2 pi part affiliation. This is second postulate. Third postulate says that whenever it's stable energy in the stable, every time whenever your electron is been revolving, that orbit always have the stable energy. So it means in a stable orbit, electron energy always remains for me constant. Every electrons remains for me. Electron energy remains for me constant. That means electron energy changes when it makes a transition from one orbit to the another orbit. And okay energy level nunchi inko energy level ko let up. During such transitions are very instantaneous and involves the quantization of energy in the form of what? Electromagnetic radiation. Ante ఇక్కడ కింద నుంచి పైకి వెళ్ళేటప్పుడు it will absorb the photon, from పై నుంచి కిందికి వచ్చేటప్పుడు it will be releasing your photon particulation. During this absorption and releases, energy has been liberated. That radiations which have been coming out when electron is coming from higher energy to lower energy is in the form of what? Electromagnetic radiation. Is it clear for everyone? So these are the three postulates which you need to remember for your competitive examination. And E2 is always greater than E1. That means it may release or absorb the energy depending upon the requirement. Okay, sure. First formula which have been useful for us to solve the numericals, that is radius of nth orbit, radius of your nth orbit in Bohr's model, in your Bohr's model. I hope you did this one already in your chemistry. Formula gurtunda, radius of your nth orbit in your Bohr's model of hydrogen atom. చూడండి, For nth orbit, all the statements, all the equations we are writing from the above three statements only, beta. M into Vn square is equals to K into Z into E square divided by radius of your nth orbit. Okay, from the first postulate, isn't it? From first postulate. Okay, from second postulate, m into velocity of nth orbit, radius of your nth orbit is equals to n into your h divided by your 2 pi. That means I can get the velocity of nth orbit from this one. Velocity of nth orbit is equals to n into your h divided by your 2 pi into your m into radius of your nth orbit. Okay, so this one is my equation number 1. This is my equation number 2. And from the equation number 2, I got the velocity of your nth orbit. Now substitute this velocity of your nth orbit in the first orbit. So I can write here from first postulate or from first equation, from equation number 1, you bring me the radius of your nth orbit. So radius of nth orbit ikkada vellipoyindi anukondi. Idi enta avutundi? Radius of your nth orbit is equals to k into z into e square divided by your m into your v into n square. You know already the value of your Rn, substitute that one. Rn is equals to k into z into e square divided by your m into velocity of your nth orbit is n into your h divided by 2 pi into your m into your Rn, and this one is your whole square. So radius of your nth orbit is equals to k into z into e square divided by, so I'm just opening the bracket, that is m into n square h square divided by, this one is 4 into your pi square em square radius of nth orbit, that is nothing but Rn square. Okay na? So now this total term will go up right now for this one. So this one is k into z into your e square. This one is 4 into pi square into your m square into Rn square divided by your, this one is m into n square into h square into your Rn. Is anything getting cancelled in this one? You see beta, this Rn and this square will get cancelled. This square la e mass will get cancelled. Is anything getting cancelled else there beta? Nothing kada. So from this one I can get the radius of your nth orbit. So radius of your nth orbit will be equal to how much? Rn. So Rn will be equal to, ఇది ఇక్కడికి వెళ్ళిపోతే ఇది ఇక్కడికి వెళ్ళిపోతుందా? So n square into h square, and this term will come down. So this one will be equal to your n square into h square divided by, this one is your 4 into your pi square k into your z into e square into your m. So radius of your nth orbit is equals to, all the constants I'm taken one side, h square is a constant, 4 into pi square is a constant, k is a constant, e square value is a constant, m is also your constant. The thing which is been variable in this nothing but of your orbit, so it is your n square divided by your atomic number, that is nothing but of your z. Okay, so if I simplify this total value of this one, because I know all the values in this one now beta, so I know the values of this one, all the values, Planck's constant value తెలుసు మనకు, pi square value తెలుసు, k value తెలుసు, charge of electron తెలుసు, mass of electron తెలుసు. If I simplify all this part of relation, so I'll be getting this one as radius of your nth orbit is equals to 0.529 into, this one is n square divided by z. Unit is for this one angstrom. So this is the radius of your nth orbit formula. So this is a direct shortcut formula you need to remember. Radius of your nth orbit is calculated by the formula Rn is equals to your 0.529 into 10 n square divided by your z square part of relation. So this is a very important relation you need to remember for your competitive examination. Okay. So radius of your nth orbit is this one. In the same way, velocity, next one. Velocity of electron in nth orbit, in your nth orbit in Bohr's model. in your Bohr model. Velocity of electron in nth orbit in your Bohr model. Okay, see here. As radius of your nth orbit is equals to h square n square. ఈ ఫార్మ్స్ అన్ని గుర్తుపెట్టుకోవాలి నాన్న, లేకపోతే చాలా కష్టం. Divided by 4 into your pi square k into z into e square into your m. Okay, radius of your nth orbit. So from second postulate, from second postulate, that is m into velocity of nth orbit, radius of nth orbit is equals to n into, this one is h by your 2 into your pi. We need velocity of nth orbit. Velocity of nth orbit is equals to n into your h divided by 2 pi into your m into radius of your nth orbit. Substitute the value of your radius of your nth orbit in this one. So it is n into your h divided by your 2 pi into your m into radius of your nth orbit formula. Radius of your nth orbit formula ఎంత ఉంది చూడండి ఇంతకు ముందు, h square n square this value. So this one is your h square n square divided by your 4 into your pi square. This one is your k into z into e square into your m. అంతేనా? z into e square into your m అంతే. ఇదని క్యాన్సిల్ అవుతున్నాయి చూడండి ఒకసారి దీంట్లో. సో 2 1s are 2 2s are, this pi square లా ఈ స్క్వేర్ ఈ పై వెళ్ళిపోతుంది. ఎనీథింగ్ ఎల్స్ ఈస్ గెటింగ్ క్యాన్సిల్ ఇన్ దిస్ వన్ బేటా. ఇంకేమైనా ఉందా?
సో NH.
n and h. యా, ఇది ఒక n, ఇది ఒక స్క్వేర్, ఇది ఒక h, ఇది ఒకటి. ఇంకేమైనా పోతుందా?
సో MM.
M is also getting cancelled kada. So this m and this m is also getting cancelled. So velocity of nth orbit ఎంత వస్తుంది చూడు. Velocity of nth orbit is equals to ఎంత వస్తుందన్న?
2 pi k z square by NH.
2 pi k z into e square divided by n into your h. అంతేనా? Yeah. So this will be the velocity of your nth orbit. So I can here write velocity of your nth orbit is equals to 2 pi is a constant, k is a constant, e square is a constant, divided by your h is also constant. The one which is been variable is atomic number and as well as of your n. ఇది మొత్తం కాన్స్టెంట్ కదా. ఈ మొత్తం కాన్స్టెంట్స్ లో అన్ని వాల్యూస్ మనకు తెలుసు. ఇఫ్ యూ సింప్లిఫై ఇట్, వెలాసిటీ ఆఫ్ your nth orbit is coming out for me 2.18 into 10 to the power of 6 z by your n. Unit is meter per second. So this is the velocity of your nth orbit formula. This value is approximately equal to velocity of your nth orbit is equals to velocity of light divided by your 137 times into your z by your n meter per second. So this is the velocity of your nth orbit shortcut formula. So if I need to calculate the velocity of your electron in the nth Bohr's model, I can use this relation for this one in terms of your velocity of a light divided by your z by your n part of relation, where c value is nothing but how much beta? C value is equals to your 3 into 10 to the power of 8 meter per second. So that is the way how we got the velocity of your nth orbit. You can also remember this formula as a standard formula beta. ఈ ఫార్ములాస్ కూడా కొన్నిసార్లు అడిగాడు డైరెక్ట్ గా వాడు ఇన్ టర్మ్స్ ఆఫ్ కే వాల్యూస్. కే వాల్యూ ఎంత? 1/4 pi epsilon naught. సో ఈ వాల్యూస్ కూడా గుర్తుపెట్టుకోవాలి. లిటిల్ బిట్ ఆఫ్ ప్రాక్టీస్ విల్ హెల్ప్ అవుట్ టు రిమెంబర్ ఆల్ దీస్ వాల్యూస్. ఓకే, సో వి గాట్ ది వెలాసిటీ ఆఫ్ యువర్ nth ఆర్బిట్. ఓకే, ఇప్పుడు మనకు ఏమేమి వచ్చాయి చూడండి. ఇక్కడ రేడియస్ ఆఫ్ nth ఆర్బిట్ వచ్చింది, వెలాసిటీ ఆఫ్ యువర్ nth ఆర్బిట్ వచ్చింది. Now in the same way as electron is revolving in circular orbit, it also has one more type of a speed. I hope you remember that one. That is your angular speed. Circular path lo move avutundi kada. So angular speed of your electron in nth orbit, in your nth orbit, in your Bohr's model, in your Bohr model will be equal to your how much? So So we are talking about your angular speed of your electron in your nth orbit in your Bohr's model. How do you calculate the angular velocity? Can anyone tell me beta? Circular motion lo meeku formula undi. Velocity of your nth orbit is equals to radius of your nth orbit into angular velocity of your nth orbit. V is equals to r omega. So we need to calculate angular velocity of nth orbit kabatti this one is Vn divided by your Rn. So that is equals to Vn value is 2 pi into k into e square into z divided by your n into your h divided by radius of an nth orbit is your h square into n square divided by this one is 4 into your pi square k z into e square into your m. Okay, so దీన్ని కొంచెం సింప్లిఫై చేసుకుంటే this one is your 2 pi k e square into z divided by your n into your h into this value will go up here. So this one is 4 pi square k z into e square into your m divided by your h square into your n square. Anything is getting cancelled in this one beta? చూడండి ఏదైనా క్యాన్సిల్ అవుతున్నాయా? ఏమీ లేదు క్యాన్సిల్ అవ్వడానికి. ఎన్ లేదు, హెచ్ కూడా పైన లేదు, n square కూడా లేదు. So nothing is getting cancelled in this one. So if it is nothing cancelled means omega of your nth orbit will be equal to your multiply చేయండి 4 into 2 8. So it is 8 pi square into pi. This will be pi cube k square z into z z square e square into e square e to the power of 4 h into h square h cube n into n square n cube. Okay na? So I can write that one right now here as this one is your 8, this one is your pi cube, this one is your k square, this one is your z square e to the power of 4 into your m divided by your this one is your n cube into your h cube. That means angular velocity of your electron in the nth orbit is equals to all constants ni బయటికి తీసుకొచ్చేసేయండి 8 into pi cube, this one is k square e to the power of 4 into your m divided by your h cube will be the constant into మిగిలినది ఇక్కడ z square divided by your n cube. So that means angular velocity of your nth orbit is directly proportional to z square divided by your n cube. This formula will be useful for your numericals. Okay, so ఈ ఫార్ములా మాత్రం గుర్తుపెట్టుకోండి. ఇది మొత్తం కాన్స్టెంట్. సో m to the power of ఇదంతా m కదా, ఒకటే కదా m, e to the power of 4. ఇది కూడా చాలాసార్లు అడుగుతుంటాడు. Angular velocity of nth orbit is proportional to the electron to how much power? E to the power of 4. So angular velocity of this one is omega n is directly proportional to your z square divided by your n cube part of relation. Very, 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 very important formula. So please be attentive with this type of your relations. Important formula. Okay. So now see, once you know the angular, what do you call that one, velocity of this one, you can calculate the frequency also. Angular frequencies వచ్చాయా? దాని తర్వాత if I am talking about right now, next one is angular speed of this one, and next one is nothing but of your revolution frequency. Revolution frequency and time period of electron in nth orbit, in your nth orbit, Bohr's nth orbit. So we are talking about your revolution frequency, we are talking about your time period of this electron in the nth orbit part of relation. Now we know that omega of your nth orbit is equals to 2 pi into your frequency of your nth orbit. That means frequency of your nth orbit is equals to your, how much I can write here? Frequency of your nth orbit is equals to omega into your n divided by your 2 pi. We already know the value of your omega, isn't it? So that value we can substitute here right now. So frequency of your nth orbit will be equal to your 8 into pi cube k square e to the power of 4 into your m divided by your, this one is your h cube into z square divided by your n cube divided by your 2 pi. అంతే కదా, divided by your 2 pi. So ఇది ఎంత అయిపోతుంది చూడండి, this will cross multiply this one. So 2 1s are 2 4s are. This one will go here right now 1 and ఇది square ని cut చేసుకొని square అయిపోతుంది. So this will become for me 4 into your pi square k square e to the power of 4 into your m divided by your h cube into this one is z square divided by your n cube. Okay, therefore I can say that frequency of your nth orbit is also directly proportional to your z square into directly proportional to your n cube. This is also important relation. Both of them we are having the same formula. Okay, so now once we know this one, we can calculate the time period, isn't it? So time period will be equal to your how much? Time period of revolution of electron. Time period of revolution of your electron. So if I'm talking about the time period of revolution of electron, once I know the frequency, I know how to calculate that one, because time period is inversely proportional to your frequency, isn't it? That means that will become for me your h cube divided by, that will become reciprocal kada, 4 into your pi square. This one is nothing but of your how much for me? Frequency ఎంత వచ్చింది ఇది k. FNA kada, so it is pi square e to the power of 4 into your m h cube పైన వెళ్ళిపోయింది into this will become for me z square divided by your n cube. అంటే reciprocal కదా ఇది, sorry. అంటే this will become for me n cube divided by z square. అంతేనా? క్లియరా బేటా? That means I can write here time period of nth orbit is directly proportional to your n cube by your z square. This formula is important for. That's it. Okay, so ఈ రిలేషన్స్ లా ఇవన్నీ గుర్తుపెట్టుకోవాలన్న, స్టాండర్డ్ రిలేషన్స్ కూడా గుర్తుపెట్టుకుంటే హ్యాపీ. అగైన్ ఫైనల్ ఇవి మాత్రం వెరీ వెరీ ఇంపార్టెంట్ ఫర్ యువర్ కాంపిటేటివ్ ఎగ్జామినేషన్స్. ద నెక్స్ట్ వన్ ఇస్ కరెంట్. కరెంట్ డ్యూ టు రెవల్యూషన్ ఆఫ్ ఎలక్ట్రాన్ రివాల్వ్ అవుతుందంటే ఇన్ సర్క్యులర్ ఆర్బిట్ కరెంట్ ఈస్ బిన్ ప్రొడ్యూస్ కదా ఆఫ్ యువర్ ఎలక్ట్రాన్ ఇన్ nth orbit, in your nth Bohr's orbit. So we are talking about your current due to your revolution of electron in your nth orbit. How do you calculate the current formula beta? Current formula చెప్పండి in nth orbit. In is equals to q by your t, charge divided by time. So it is E divided by 2 pi into your angular frequency omega n. And this will become for me E omega into your n divided by 2 pi. Or else this one can be written as of your E into your frequency. So In is equals to 4 into your pi square k square. This will become for me e to the power of 5 into your m divided by your h cube. Okay, ఎందుకంటే ఈతో మల్టిప్లై చేస్తున్నాం కదా, ఫ్రీక్వెన్సీ ఆల్రెడీ ఎంత ఉంది చూడండి. ఈ ఫ్రీక్వెన్సీలో చార్జ్ ఈజ్ ఆల్రెడీ e to the power of 4, అది ఎక్కడ ఎలక్ట్రాన్తో మల్టిప్లై చేసుకుంటే e to the power of 5 అయిపోతుంది into your m into this one will become for me z square divided by your n cube. So current in your nth orbit is directly proportional to your z square divided by your n cube. Again, this is also an important relation. Okay, దాని తర్వాత magnetic induction. Moving charges will produce the magnetic field also kada. So if I'm talking about your magnetic induction at nucleus, due to electron revolution in nth Bohr's orbit. These are all only for your hydrogen like atoms. Okay, so when electron is revolving in the circular orbit, isn't it? In the center we are having your plus ZE. ఇక్కడ వచ్చేసి plus Z into your E. This is your radius. This is nothing but of your radius of your nth orbit, and charge of electron is nothing but this one. So this is velocity of nth orbit. Here is the electron which is been revolving. So if electron is produced in this one, current is being produced in the nth orbit in this direction, because electron is moving in this direction. Opposite to the flow of a current electron, the current will be produced. So magnetic field at the center will be equal to how much better? Magnetic field at the center is equals to mu naught into I into your n in the nth orbit of current divided by 2 into radius of nth orbit. So that is equals to mu naught into current in the nth orbit is 4 into your pi square k square is to the power of 5 z square into your m divided by your 2 into your, this one is how much for me here? This one is nothing but of your n cube into your h cube. This one is 2 into this one is how much right now for me beta? A radius of your nth orbit. Antena? So radius of your nth orbit formula in the this one. This is nothing n square h square, go on for the given condition. So radius of your nth orbit we got the given condition right now. So write the relation right now for that one. That will give me the answer for the given part. This one is this one. So if I am writing the radius of an nth orbit formula, this one is your n square, this one is h square divided by, this one is 4 into your pi square k into your z into your e square divided by your m. Antena? 4 into pi square into k z into e square into your m. So if I simplify this one, magnetic field at the center is directly proportional to this one will come out for me 2 1s are 2 2s are ikkadanta 2 1s are, this one is 2 2s are, 5 not 2 వెళ్ళిపోతే 8 అయిపోతుందా. So this one is 8 into 5 to the power of 4. This one is mu naught k cube into z cube e square m square divided by your n to the power of 5 and h to the power of 5. That means magnetic field of your nth orbit is directly proportional to your z cube divided by your n to the power of your 5. Again, this is again important formula.
Sir, can e to the power of 7, sir?
Edra e to the power of 7 ఎట్లయితదిరా?
అవును సార్ e⁴ సార్.
నేను తప్పు చేస్తాను. కొంచెం 5 పైకి వెళ్ళిపోతుంది కాబట్టి e to the power of 7, సారీ e to the power of your 7. అంతేనా? ఓకే, ఈ రిలేషన్స్ లో ఇవన్నీ ఇట్లా ఇవి గుర్తుపెట్టుకుంటే చాలా. Radius of magnetic field to nth orbit in the Bohr's orbit is directly proportional to z cube and inversely proportional to your n to the power of your 5 part of relation. Very, very, very important relations. Even you metal problems చేసేటప్పుడు you'll be seeing this type of a conditions there. The next one is magnetic moment. Magnetic moment due to electron revolution in nth Bohr's orbit. In your nth Bohr orbit. So we're talking about your magnetic moment due to electrons revolution in your nth Bohr's orbit. Magnetic moment formula చెప్పండి ఎవరైనా చెప్తారా? Magnetic moment is equals to what? I into A కదా. So current in your nth orbit into your area. Number of turns into n రాసుకోవడమే. So it is nothing but of your in into area వచ్చేసి pi into radius of your nth orbit. So in will be equal to how much beta? Radius of your current in the nth orbit is 4 into your pi square. This one is k square z square e to the power of 5 into your m divided by your n cube into your h cube into this one is pi into radius of your nth orbit into your radius of your nth orbit రాసుకుంటే ఇది ఎంత అవుతుంది ఇక్కడ? So this one is n square h square divided by your 4 into your pi square k into z into e square into your m. ఇది మొత్తం సింప్లిఫై చేసుకుంటే you will be getting magnetic moment of your nth orbit is equals to E into n into your h divided by your 4 pi into your m. So for n is equals to your 1 if I am writing. So magnetic moment m1 is equals to E into your h divided by your 4 pi into your m. This value is called as of your very important term Bohr's magneton. Bohr's magneton. Bohr's magneton. Okay, E into h by your 4 pi into your m part of relation. So this is the basic formula which you need to remember. Magnetic moment of your nth orbit is this much. So these are the some of the important relations. You just practice this one and you start doing the numericals on your Bohr's model on this one. Okay, alpha scattering experiment ఒకటి ఉంది నాన్న. How do you calculate the impact parameter distance అనేది ఆ ఫార్ములా ఒక్కసారి మన టెక్స్ట్ బుక్ మెటీరియల్ go through చేయండి. That will help you out for the given condition. In the Rutherford's what do you call that one, Riggers metals experiment ఒకటి ఉంది బేసికల్ గా an impact parameter and fraction of alpha particles scattered at an angle. How do you calculate? Formula ఉంది దానికి అక్కడ n is directly proportional to z square inversely proportional to sin to the power of 4 theta by 4 అనేది. సో యాక్చువల్ ఫార్ములాలో గుర్తుపెట్టుకోండి. దట్ విల్ హెల్ప్ యూ అవుట్ ఫ్రమ్ దట్ వన్. మెటీరియల్ స్టార్టింగ్ లో ఉంది, అది ఒక్కసారి గో త్రూ చేయండి. ఆ ఫార్ములా యూ హ్యావ్ టు రిమెంబర్ ఇట్ బెటర్ బై హార్ట్. దెర్ ఇస్ నో అదర్ ఆల్టర్నేట్. So this one was something related to your atomic structure. This date today 15 kada. అందరికి వచ్చేసి చూడండి మెటీరియల్.